Okay, Unit 1 review for the geometry final. I'm not going to write out all of these just because it's time consuming and you know my handwriting. I'm going to talk through the definitions and I will draw a picture. So, supplementary and complementary angles. Remember my little trick for remembering that? C comes before S in the alphabet and 90 comes before 180. So supplementary angles, key is 180 degrees and complementary is 90 degrees. So a picture would be the obtuse angle looks like that, and the acute angle looks like that. And they don't have to be joined, if they are, then it makes a linear pair. But basically, any two angles like so. And for complementary, if I had a 30-degree angle here, and a 60-degree angle here, those two are complementary. Put those together, they'd make a 90-degree angle. Vertical angles are formed by two intersecting lines. They're opposite of each other, and they're congruent. Okay? Let's put out some key words. You also have top and bottom. Different values, but vertical. Congruent. Coplanar. We usually do like a slanted shape for a plane. Coplanar just means on the same plane. But they can't all be in a line, because otherwise, what distinguishes a line from a plane? Collinear means on the same line. Okay, it's like point D up here would not be collinear. Point D out here, if we were thinking three-dimensional space, would not be collinear. A linear pair gets back to what we were talking about in number 1, but these two angles are actually touching. They must share a common vertex and a common side, or ray. And they must add up to 180 degrees. Midpoint of a segment, this is very important. On the one quiz, a lot of people did stuff like this. For one thing, a lot of people put lines, and you can't do that because it has to have endpoints. So you can know where the middle is. That is not enough. We don't know that B is in the middle until we have some kind of marking showing that the two sides are equal. Perpendicular bisector. That is not enough to make a perpendicular bisector. It must come in at 90 degrees and hit the midpoint. Must cut it in two. An angle bisector splits an angle into two equal sections, two equal parts. Parallel lines, just like the symbol grid pretty much, parallel lines never meet. They will never touch. They're the same distance apart. They have the same slope. Skew lines, it's a little tougher. So, if I have a three-dimensional object, and I want to talk about what is skew to this line. Well, let's go through and say what it can't be. Skew lines cannot be any of these lines that are parallel to that line. When I say parallel, I mean, you could do this, and the line's parallel. It also cannot be touching the green line. So that one's out, and that one is out. So is this. So is this. only skew lines are the ones that remain in blue, that are neither touching nor parallel. So, key, not touching, and not parallel. Very key. Okay, here we go. The intersection of two lines is a point. And the intersection of two planes is a line. Okay, always, sometimes, never. Segment AB is always the same as BA. The order in which you name it does not matter. If I said AB was 6 inches, 6 feet, 6 miles, BA is also the same. The intersection of two distinct planes is always a line. Okay. Number 6. Through any three collinear points, there is never only one plane. That's a tricky one to say never to, because there is going to be a plane surrounding that line, but in the fact of naming it, we don't use three collinear points. So that's a tricky one. The main thing you want to get out of this one is three collinear points do not name a plane. They name a line, but not a plane. Complementary angles, number 7. Complementary angles never have sum of 180. That's supplementary. And two lines are sometimes coplanar. Okay? So think about it. If I had a box, okay, I can draw a line on the top of the box. I can draw another line on the top of the box. They're coplanar. But if I draw a line on the top of the box and one on the front of the box, they're not coplanar. Okay, the figure below, or to the right, name two intersecting lines. This is, there's so many right answers here. Just draw a line. Pick one, AD. At that point, you can have any line that's touching A or D, such as AB, or AD, or DC, AE, or DH. Any of those would work. Notice they both have a D in them. That's the main important point. No pun intended. Name three non-collinear points. Pick any 3 points on there, because if you actually look at it, there are no 3 coplanar points. So any 3 points you pick are not going to be on the same line. So B, G, and E. Point B, point G, and point E. Name 3 lines that intersect at D. Well, again, DH, DG, DA. DC. Okay, so DA, DC, and DH. Identify the intersection of ABF. So let's see what that is first. ABF. That is the left side as we're looking at it. And line EH. Where do those hit? Right there at point E. Now, even though there's no E in here, that's just because they didn't use that one, but you could have used that to name it. They just didn't use that one to kind of be tricky. Identify the intersection of FG and AB. FG and AB. Where do they intersect? They don't. Identify the intersection of plane ADC, so let's mark that first. ADC, that's the front of the box. And point B. Well, that's point Identify the intersection of plane HDG. See what that is. HD, G, you don't have to go in order, but it's basically the right side of the box. And EC. That's a diagonal line that we don't, it's not drawn, but it is a line. We could draw a line, so it counts. So where do they count? They meet point C. So that was tricky for two ways, because HGG is not in order as you go around the box, and EC is not drawn, but it can be connected. Identify the intersection of plane EAD. Let's see what it is. EAD. That's the top of the box. And the plane HGF. HGF, that's the back of the box. Where do they meet? At line segment EH. Okay, 17. Angle 1 is 118 degrees. What's angle 3? 118 degrees, because they're vertical. If we wanted to find 2 or 4, it'd be 180 minus 118. Which would be 62. So, bonus round. 2 and 4 are also equal. 18, find the values of the variables. Show your work. Okay, well, these two are vertical, so we can set them equal to each other. Subtract 4. Divide by 4. And x equals 29. Now, there's a bunch of ways you can solve for y. We know that if this is 120 right here, and this is a line, this must be 60 degrees. So you could just say 2y equals 60. Therefore, y is 30. If you didn't see that, you could say 2y plus 120 equals 180. Well, guess what? When you subtract 120, look what you get. Same step as before. So y is 30 and x is 29. Okay, 19. Determine whether they are complementary, supplementary, or neither. Well, number 19, 148 plus 32. 8 plus 2 is 10. 4, 5, 6, 7, 8. 180 degrees. Supplementary. 46 and 44. 6 plus 4 is 10. 4, 8, 9. Complementary. 46 and 43. Well, we just proved that 46 and 44 make 90. This makes 89, so neither. Supplementary angles are two angles whose measures have the sum of 180 and complementary and up to 90. We already talked about that. The measure of an angle is 3 times its common. Okay, there's not a lot of space here. So, first we have our first angle. We'll call it x. Our second angle, which is the complement, is 90 minus x, right? If we knew the first angle was 30, we would do 90 minus 30 to get 60. So we take 90 minus the angle to get its complement. So let's just read what this says. The measure of an angle, x, is 3 times its complement. What's the measure of the angle? Well, next step, we're in a lot of room here. X equals 270 minus 3x. Add 3x to both sides, you get 4x equals 270. Which leads to, if you divide by 4, x equals 67.5 degrees. And if you divide that by 3, you get 22.5. And those two together add up to 90. The measure of an angle, we'll call x, And we're talking about the supplement. So that's 180 minus x. So let's just read what it says. The measure of an angle is half the sum of its supplement, which is 180 minus x and 30. Now, lots to do here. I personally like to get rid of that 1/2, so I'm going to multiply by 2, both sides. Which on the left side gives me 2x, on the right side just gives me the 180 minus x plus 30. And 180 plus 30 is 210 minus x. Add x to both sides. That gives me 3x equals 210. And so therefore, x is 70. I do apologize. I told you guys to change it from 70 to 40. The 70 was correct. I believe I made a mistake when I was working that problem and I read it as complement, so I did 90 minus x on both of them, and that's why I got 40. So I do apologize. The answer is, in fact, 70. Okay, find the value of the variable. Well, this angle and this angle form a straight line, which means they are supplementary, which means 2x plus 144 plus 4x plus 18 equal 180 degrees. So we join like terms, 6x plus 4 to 12, 4, 5, 6, 162 equals 180. Now if I subtract 162, I get 18, and divide by 6, x is 3. B is the midpoint of AC. It says AB is 2x plus 10. BC is 3x minus 5. Notice they're equal to each other. So I just do that. I'm going to subtract 2x from both sides and add 5 to both sides. X is 15, but that's not what it asks. It says find AB. So AB, when I plug 15 in, 2 times 15 is 30, plus 10 is 40. 25. B is between A and C. AB is 3x plus 5. BC is 4x minus 2. And the whole overall AC is 66. So this plus this equals that. So 3x plus 5 plus 4x minus 2 equals 66. That means 7x plus 3 equals 66. I minus 3 to both sides, I get 7x equals 63. And when I divide by 7, I get 9. And then it says, solve for each segment length. So AB, 9 times 3 is 27, plus 5, 32. BC, I could just do 66 minus 32, or 9 times 4 is 36, minus 2 is 34. And if you add those together, you get 66, so it works out. 26. It says if B is between A and C, and BA is 32, and CA 78. What is x? Well, that's quite simply 32 plus x equals 78. Subtract 32. X is 46. Okay, reflect reflection means to do what? Well, when you reflect something, you flip it. Reflect over the x-axis. Well, this is the x-axis. Make sure you know where it is. Now, for this one, all you do is count. N is 1 above, so n prime is going to be 1 below. I is 2 above, so there's I prime. And M is 1, 2, 3, 4, 5 above, 1, 2, 3 basically down here, M prime. So I prime is at -2, -2. M prime is at -2, -5. And N prime is at -5, -1. Reflect over the y-axis. That's right here. N prime is not going to change because it's on the axis. So N prime remains 0, 1. But then G is 2 left, so I'm going to go 2 right. There's G prime. Q is 1, 2, 3, 1, 2, 3. There's Q prime. And X is 2 over. So there you go. So G prime is at 1, 2, 4. Q prime is at 4, 1. And X prime is at 2, -1. Translation means to move or slide. I don't know what that 5 is there for. That's not on. I don't believe that's on your paper. Let me check. Apologize again. Oh, this will be 31. I don't know why it says. This is supposed to be 31. So, given a vector of -2, remember, this is your x, this is your y. This is your left and right. This is your up and down. So this means to go left 2 and up 4. Left means negative or down. Up means right or, positive means up or right. Okay, that makes this 32 and this 33 on your answer key, sorry. Translate the following images. So basically, this is x, this is y. We're going to go left 2 and down 1. So each point, we're just going to go left 2, down 1. Left 2, down 1. Left 2, down 1. Left 2, down 1. There's W prime. There's, I don't know what point that is, J prime. Here's X prime, and here's P prime. So J prime is -2, +4. Which is a typo on your answer key. It says +2, but it's -2. Oh wait, no it's not. I'm wrong. Sorry. I just got done saying positive means right, and I just wrote left. I'm sorry. Right 2, down 1. So let's try this again. Right 2, down 1. There's J prime at 2, 4. Answer key is wrong. Being right, but I'm wrong. 1, 2, 1. There's W prime. 1, 2, 1. There's P prime. And 1, 2, 1. There's X prime. So W prime is at 5, 0. P prime is at 0, -2. And X prime is at -1, 0. Sorry about that. Okay, 7, 4. Let's pay attention here. Right 7, There's D prime. R is going to be 1, 2, 3 left of it. R prime. And Q, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. There we go. Q prime. So R prime is at 2, 4. D prime is at 5, 4. And Q prime is at 3, negative 1. Okay, this is printed wrong. This is on a new page for you. But a rotation means to do what? To spin. And unless otherwise, or turn. And unless otherwise, they rotate in what direction? Counterclockwise. So unless we tell you to go clockwise, we're always going counterclockwise. Okay. Rotate it 90 degrees. Okay. So when you rotate, let's talk about what they are right now. So T, J, Y, and X. T is at 1, 0. This helps to do this. J is at 3, 0. Y is at 2, negative 3. And X is at 1, 2, 3, 1, 2, 3, 4. 3, negative 4. So this helps because 90 degrees, if we rotate 90 degrees, and don't forget this is 36, and this is 37. So we rotate 90 degrees, T is going to go from 1, 0 to 0, 1. J is going to go from 3, 0 to 0, 3. And now what happens, and 0 isn't affected, but on Y, it's going to go from 2, negative 3 to 3, 2. What happens is they switch places and you take the opposite of the Y. So if you look at X, negative 4 is going to move to the front, but become positive, and the 3 is just going to move over here. 4, 3. So then we want to do 0, 1, T prime, and 0, 3, J prime, and X is going to be at 4, 3, X prime, and Y is at 3, 2, Y prime. And you can kind of imagine this kind of rotating, but when it rotates, I can't really do it here, do it justice, but it's rotating like 90 degrees. But when it does that, it's also doing that. So it's hard to manipulate it exactly, but the whole thing, I can't rotate it and spin at the same time, and rotate and slide it. But basically, this point is rotating there. And this point is rotating there, and that's rotating and rotating. That's what's happening. Okay? So 180 degrees on this one. So this is a little bit different for 37. Let's again, we already have our reference points over here on 36. We're just going to use the same ones. Now with 180, it's a little bit different. We're just going to take the opposite of X and keep Y the same. So we had 1, 0, it's going to be negative 1, 0. And instead of 3, 0, it's going to be negative 3, 0. For 2, negative 3, it's going to become negative 2, positive 3. In other words, everything's becoming its opposite. There is no opposite of 0. And 3, negative 4 is going to become negative 3, positive 4. Because we wanted to end up in this quadrant. So here's negative 1, 0. Here's negative 3, 0. There's Y prime. 180-degree rotation. 270, we're going to start with the same points, okay, and we're going to rotate 270 degrees. Now this time, let's get down, let's talk about it. Look at the original points. So let's look at y and x, because those don't have zeros. So we had 2, -3. So the y is going to move into the x position, and the x is going to become opposite. So up here, for x, -4 is going to move forward to the x position, and the 3 becomes opposite. So 0, -1, 0, -3, -3, -2, -4, -3. And there's our same shape, sort of, not very well drawn. Okay, composite of transformations. This is when you do 2 in a row. So you do one thing and then you do another thing. You can rotate, then slide. You can rotate and then rotate again. You can rotate and reflect. You can do any of the combinations of what we've done. So ABC. So 1, 3. 1, 1, 2, 3. -2, -1. 3, -2. A, B, C. There's one triangle. Now it says translate it to 0, which means write 2 and then don't do anything else. So write 2. So A prime, B prime, and C prime. So A prime is now 1, 2, 3, comma 3. And B is 0, -1. And C prime is 5, -2. Notice all we did was add 2 to each of these. 1 + 2 is 3, -2 + 2 is 0, 3 + 2 is 5. Now reflect across the y-axis. So again, the y-axis is right here. Notice that B prime is now on the axis, so it's going to stay in the same spot. 0, -1, it's not moving. C is 1, 2, 3, 4, 5 away, so I'm going to go 1, 2, 3, 4, 5 away this way. And A is 1, 2, 3, 1, 2, 3. And there's my new location. So A double prime is at -1, -2, -3, up 3. And then this is going to be at -5, -2. Notice the x's just changed from positive to negative. And the y's did not change at all when we reflected. Okay, DE has vertices at 1, 3, 1, 3, and 3, -3. Translate -2, -1. That means left 2, down 1. So left 2, down 1. Left 2, down 1. E prime, D prime. So where is D prime at? -1, +2. B prime is at 1, -4. Just check. E, move left 2, down 1. Yes. The answer key is wrong. It should be -4, not +4. now a rotation of 270 degrees. Remember when we rotate 270 degrees, okay, the x and the y switch, but x becomes negative. So the negative 1 is going to move here and become positive, and 2 just goes right there. And the negative 4, again, sorry, the 1 is going to become negative 1, and negative 4 just moves and stays the same. And so now when you draw that, different color, but sorry, 1, 2, 1, so there's D double prime, and negative 4, negative 1. There's E double prime. Oops, I didn't go far enough. I only went 2. 1, 2, 3, 4. Yeah, I didn't look well enough. There you go. E double prime. Okay, in transformation. Again, this is 42, 43, and 44. So on this one, all we did is we slid. Okay, that's translation. You know, we might have gone right 3, down 1, or something like that. Okay, 43, you can see how it kind of spun down. That's a rotation. And then over here we have a reflection. They're staring at each other in the mirror. Okay, that's it.